In this video, we will try to understand how we can write optimization problems in mathematical forms, what are the design variables, constraints, and objective function. We can express any real-life optimization problem mathematically as find x, which minimize function fx. Here x is n-dimensional vector that is also known as design vector, fx that is objective function. Optimization problems are categorized as constraint based optimization problems and unconstrained based optimization problems. Unconstrained optimization problems do not have any constraint. For example, you can see here, this is unconstrained optimization problem, find x, which minimize a function fx, and here we have no constraints. Next, you can see here constrained optimization problem, find x, which minimize function fx. It's subject to different inequality and equality constraints. This is the inequality constraint, and here this is the equality constraint. So as you can see here, we have inequality and equality constraints. So we can call this equation constraint optimization problem. Here n is the total number of variables, m total number of constraints. So we can express any real life optimization problem mathematically using objective function and the constraints. Next, we have design variables. Engineering systems are defined as set of qualities that are used as variable during the design process. We have fixed qualities, that is also known as pre-assigned parameters, and other qualities are called design variables or decision variables in the design process. So we have fixed qualities, that is also known as pre-assigned parameters, and other qualities are called design variables or decision variables in the design process. For example, you can see here we have welded beam optimization problem. So we have the objective function minimize fx, and it's subject to different inequality constraints. And here you can see we have different fixed qualities, that is the pre-assigned parameters, and other qualities are known as decision variables or design variables. So here we have different design variables like x1, x2, x3, x4, x1 that is h, x2 l, x3 that is t, and x4 that is b. Next, we have objective function that we formulate to solve any optimization problem. Optimization objective is to select the best among all, and as we know, optimization primary goal is to save time, money, and resources. Suppose we want to manufacture any product A at minimum cost. So here you can see, suppose we have any product A and we want to manufacture this product at minimum cost. In structure designing, optimization objective is to minimize the cost. So one of the most important decision in entire optimum design process is the decision of the objective function. Here you can see another real life optimization problem, that is wind farm layout optimization problem, where we want to optimize the wind farm layout for the maximum energy production at minimum cost. So here we want to place the wind turbines at the different locations so that it will generate more electricity, and the overall construction cost and other cost is minimum. So when we want to achieve multiple objectives for any optimization problem, multiple objective functions are formulated, that is also known as multi-objective programming. Here the linear combination of multiple objective function is used to reduce the conflicts. So first we will identify what we want to minimize or maximize according to the optimization problem. Then we will express that problem mathematically using different constraints and objective function. Next, we'll formulate the objective function for the optimization problem. For example, for this pallet beam optimization problem, here you can see this is the objective function and then different constraints, pre-assigned parameters and the design variables. Next, we will select the best optimization technique to solve the problem, and here we will apply the objective function to find out the minimum or the maximum value according to the problem.